So this is the next project. What have we got here then? This is a Ford flathead V8 engine from actually from a van, like a small van that was built around 1937 in the UK by Ford, using engine and gearbox parts and transmission shipped from the US. So this means if I use this in a vehicle, a hot rod, then I can qualify as a hot rod to join the Vintage Hot Rod Association. Well, this engine and gearbox have come from a van. The owner wanted to keep the chassis and VIN number and documentation because it was built in the UK for another hot rod. I don't need the chassis, I'm going to build my own, so this suits me. Now, when you buy something like this, there are no guarantees at all. The block could be cracked, who knows. I've seen a video of this engine running in 2015. I've seen another video of it running in 2019. And prior to that, it was in a museum and had been running. So I've built a test stand, as you can see here, and it's not the usual sort of just lashed together from bits of scrap iron test stand, because I want to be able to wheel it around, and in fact the engine and gearbox are at the exact height they would be if I had 31-inch diameter tyres on the rear. And you could say, well, what do you mean? The prop shaft allows you to have the engine a little bit higher or lower. Well, the reason is, in a belly tank racer, well, you can have a prop shaft. You often don't have a prop shaft. This female spline fitting here on the end of the gearbox will actually connect directly to the male input here for the differential, if we get rid of this torque tube. And on the belly tank racers, they often had this rear axle literally welded into the frame, and then the engine and box more or less solid mounted to the frame. So the differential ends up here, and you can make an adapter to bridge this gap, or what they used to do was cut this piece of the torque tube off and keep that bed, cut this end off and keep that bit, that's the bit that connects to the gearbox, and weld them together to make like a really short torque tube. Now, you might be wondering why everything looks a bit weird. I mean, these are this is the back axle, these are drum brakes, they're cable operated, but I plan to convert them to hydraulic. They have a kind of, this is a damper system. I think these are filled with oil, and it has a transverse spring. I assume the springs are really expensive to make, because instead of having two springs at the back, sort of longitudinal, like in, I don't know, like a Ford Capri, for example, or a big old American car of the 60s, 50s and 60s, they have a transverse spring, and I think that saves money, but of course it means the axle can rock forward and back quite easily. So the way they got around that was they had this rigid torque tube with like a prop shaft inside it, go up to here, and then it's been removed, but there was like a sort of ball and socket joint here which allowed the back to go up and down a little bit and move around, but it stopped the axle tipping forward or back when you accelerated or braked. So it might seem a bit weird by modern standards, but that's how it was. So this is a flathead engine because the cylinder heads are flat. It's a side valve engine, and looking at the history of these, the the main thing about them was Henry Ford wanted to produce an affordable V8 engine car. At the time, only really expensive cars had V8 engines, so the whole block is cast in one piece, and it's a side valve engine, so it includes all the so the cam is in the middle of the V, and it pushes the valves up and down, but the discs, if you like, of the valves are sort of in a row under here, opening that way. There's no rockers or anything like that at all, which keeps it simple. It means it's nothing like as powerful as a modern V8, or even a later V8, but it is simpler in terms of engineering. So there's some weirdnesses to it. For example, if you look at the exhaust ports, you might expect to see 4 on each side, but you don't. There's one here, one there, one there. This one here is actually 2 ports from the inner 2 cylinders, and the exhaust has to come across to get to here, so you're putting a lot of extra heat into the engine, which in a modern engine would be sort of if you like, taken away down the exhaust more easily. So these engines need a lot of cooling. That's one thing about them. Other weirdnesses, 2 water pumps, one here, one on the other side, one for each side of the engine, driven by a simple belt, dynamo on the top. What else? Yeah, water comes out here to the top of your radiator, goes down, and then goes back in here, and there's one each side. So your radiator has 2 top ports, 2 top hose connections, and 2 at the bottom. And the gearbox at the moment is just a simple 3-speed gearbox. It's actually, if you want to learn how a gearbox works, it's a really good one to look at, because you literally unbolt this plate, comes off, and you can see how everything works. So what's the plan? Well, the plan is I'm going to replace this. This has already been upgraded slightly, but this rather weird ignition system, this is the distributor. It's on the end of the camshaft that turns it, and of course my belly tank racer is going to resemble a Formula 1 car, if you like. The engine's right behind the seat, so the back of the seat's here with a firewall. So to keep the length of the machine down, and to keep the length of my cockpit as large as possible, because it's not very large at the best of times, I may not even have a radiator. I may move the radiator somewhere else, but basically this may go, and this will be right up against the bulkhead. So this is in a weird place if you want to adjust anything or mess around with it. So I'm going to fit an electronic ignition system, which has the multi-pointed rotor inside, and the magnetic pickup. We'll still have a rotor arm system, but I want something that generates better sparks. This is also a 6-volt system at the moment. I'm going to upgrade it to 12 volt as well. The previous owner has fitted a new this is still made for this engine, new carburetor. Looks like at least a refurbished fuel pump, and again, it seems to have done some work on the ignition, which is probably when they had it running in 2019. Now my other problem is I'm going to need to learn to TIG weld. I've got a trusty old MIG welder, which is ancient. There it is. And it's been used in all my other projects and is battered and bruised, but it still goes. But if I'm going to be welding aluminium, I need TIG welder with an AC mode. So my frame, I mentioned this earlier, isn't just lashed together. I'm actually using it to develop my TIG welding, and you can see I'm sort of getting there. There's this sort of little C-shapes, ripples in the weld here, and as I go along, here again, this wasn't too bad. I'm getting better and better, and I'm also welding up a temporary exhaust to keep the neighbours happy. So eventually these exhausts may just stick out to the side of the machine, but I'm keeping the manifolds on for now. This one's obviously been repaired. Managed to find some flanges that bolt straight up, so I'm putting together a temporary exhaust system for my test rig. There'll be some more metal work here holding a radiator. Someone's loaned me the radiator from a van. You see it's got the 2 top hoses and the 2 bottom. I filled it with water. It doesn't appear to leak. It is pretty rusty. Some of the channels are blocked, but it might be good enough to mount on the front of my test rig here. So I'm going to wheel it out to the edge of the garage and run it for a little bit, because I want to actually not just run it for a few seconds, but run it up to temperature and just check everything works, doesn't overheat, if I can, and take things from there. So my trolley has wheels, they lock, engine's at the right height. I might actually build the car around this, leaving it on the trolley. I've yet to think about that. So my temporary exhaust is nearly done, and I need to make a bracket to hold the radiator, fit a battery, wire everything up, sort out the distributor. Then in maybe a week or so from now I'll be ready for a bench test. So this is the final bit of my exhaust. It's not very pretty. I've just MIG weld tacked this to get the angle right, because it's going to basically come under here and stick out of the back here. And it's eBay's cheapest exhaust sections, eBay's cheapest silencer, all artfully welded together just to keep the noise down a bit. The other thing I've learnt the hard way is, if you're trying to do clever welding and you're getting on a bit like me and you're short-sighted and you need some glasses, don't use a £35, that's about $40 US dollars, welding helmet. I got one at a Volkswagen show. I've had it for years, it works fine, it auto dims, but I actually invested in a good quality welding helmet, partly because I'm going to be doing aluminium at some point. You need all the help you can get, and you can see it's got a big field of view. Lots of the settings are adjustable. This whole electronic section comes out. I fitted, I don't know if you can see here, this is called a cheetah lens. It slides in and it's just made of plastic, but it magnifies everything 2 times, which, I often use a pair of glasses like that if I'm doing soldering or anything with electronics. So for me it's great. The other thing is to have good light. So I've got plenty of lights in here, but I also have a few of these. They're rechargeable, and you can position them around. Obviously if you can see what you're doing, it really does help in terms of getting your welds right. One other thing, cheap manky welding gloves, they work fine, but they're not exactly subtle. Good for clearing garden waste with thorns and branches. You can get nice welding gloves made of thin leather. Again, they're worth it. In the past I just used to buy the cheapest of everything, but of course I've learnt the hard way that sometimes a little bit of quality is worth paying for. So I'm just TIG welding this silencer or muffler onto this section. So you can see I've just done that bit there. There was a drain hole there which I've plugged. So not world class, but actually a lot neater than maybe if I'd done it with a MIG welder. So that's my torch. I've got a magnetic torch holder here, which is really helpful. Welder over there, argon cylinder down there. It's a bit like when you learn to solder. It's actually easier if you use thin solder, when you're soldering electrical joints. So I bought a whole load of these welding rods. They're actually, I think they're a little bit too thick, because they take a little bit of heat to actually get them to melt. I think I'd be better off if I'd used the next size down, but you live and learn. So these are the old high tension leads that came with the engine, and this type of connector is designed to fit over the this one's been damaged, over the threaded bit here. You push it on and it clicks on to this. Now the new leads I've got have different caps, and you have to screw these little metal sort of domed pop connectors onto the plugs. You can still get them. Here they are. Okay, so I've got a set of these. I fitted them. That bent spark plug is going to be replaced, and you then carefully label everything and thread your wires through the ducting here. It comes out here and then into your distributor. Obviously all the wires are the same colour, it's quite easy to get it wrong, so I've labelled everything extremely well because I don't want to make any mistakes. You see how these two cross over. These pipes have holes in the sides, and although this engine was built to be affordable, you'll notice that they've taken the trouble to round off the edges. They haven't just cut holes here. If you look, they're rounded. I don't quite know how they've done that, so it doesn't chafe the wires. So, you know, in a way, these are quite well made. They're not just bits of tube with holes drilled. They're more than that. But they do keep the wires tidy. You might ask, why am I changing the plug leads? Well, in a belly tanker, space is pretty tight. Once these are on, you can see they stick out quite a bit. They're very easy to damage. This plastic can crack, so I'd rather use these lower profile ones, you see. So once they're on, you'll be more like that. And I'm just trying to maximize the amount of available space, because I don't know what I'll have here. You know, I've got to dream up a clutch linkage, some way of changing gear from the front of the car, so keeping everything tight and compact is just probably a generally good idea. Now, despite reading all the books, I went on the forums recently just to get some questions answered. You can see there's a blanking plug here next to the water hose to the radiator. This is obviously a great place to put a temperature sender, and I just went online to check that that's the case, and indeed a lot of people do that. And there's another one here, so I'll probably end it with 2 temperature gauges. I've also got this mysterious fitting here. See this one there and one here with a bit of flimsy pipe coming out of it. Now this is actually a takeoff to a remote oil filter, and you would return the oil, so part of the flow, only part of the oil flow goes through the filter, and it was fitted to later models, and then it would be returned here where there's also a blanking plug, where it would just drop down the back into the engine. This is the breather pipe. So that's good. These are 1/4 NPT, which is National Pipe Thread Fitting Classification. What I did was, I know they're NPT, so I measured the diameter with some calipers and then went online and found out that that diameter is actually a 1/4 NPT fitting, as is this blanking plug. So I've ordered a mechanical pressure gauge, which I'll screw in here and to measure my oil pressure when I do my initial test runs, and I'll blank this one off. The advice I've had is actually to not use the remote oil filter, because you want all the oil to be going through the engine, and it can actually reduce the oil pressure slightly which is not that great to begin with. So bearing in mind this car's never going to do long runs, I'll probably just not have an oil filter and change the oil quite often. The other mystery thing here was, what's this? This is it's on the inlet manifold. This port I assumed was a vacuum port, and it is, it turns out. And then I was thinking, well, what was it for? Because they didn't use power assisted brakes, so it was actually for the vacuum powered windscreen wiper, because this engine came out of a van built in the UK under license, so that makes sense. So I can block that off for now, cap that off, so that's good to know, because I don't want an air leak in here. It's going to affect my fuel air mixture adversely and make it too lean, so I just wanted to check that I can block that off, and I can. So you can see everything's idiot proof labelled. I really don't want to have my high tension leads connected to the wrong plugs. It just isn't a great start when you're trying to do an initial test run of an engine. I've got a frame here which will hold the radiator. So the next job is to crimp the ends onto these leads, and what you have is a set of parts like this, which have, so you cut your lead with the conductive core sticking out, bend it over the side, and then you crimp these terminals on. You can get something like a pair of pliers, which are crimping tools, which will crimp this on. and I'm a bit of a cheapskate, so I ordered this. This is just for occasional use, but you can see you crimp it first between a vice or vice grips. In this one, scrunches the ends over, and then this one tucks the edges of each sort of loop in. It almost digs in and grips the insulator of the H2 lead. So we'll see how I get on with these. Right, my first mistake was to thread these through the wrong way around. So I've been threading them in the side holes, having them come out the end here. Of course, these go into the distributor, so actually I need to thread everything up from that way and then fish them out through the side holes. So I'm currently using a piece of red reasonably rigid wire as a guide, feeding it in, pulling it out of the side holes with these things which are like medical forceps. You can see I can just about grab the end there. Probably not. I'm filming it. Anyway, you get the idea. Oh, here we are, and pull it out like that. Right, so now I can tape the end of the HT cable to that and pull it through, hopefully. I've done it like this rather than side to side because I don't want to make it any fatter, otherwise it won't fit past the other wires. So let's see if we can gently persuade that through and out of here now. Well, success. There we go. Right, just another 7 left to go. Well, that was an hour wasted, but as you can see I've now got all these correctly routed each side, so they're coming out of the holes here. You've got to slip these rubber boots on and there before you crimp on these terminals. So the only way I could do it, because the two types of rubber stick together, was to lubricate this and the inside of this with a little bit of silicone grease, which is not flammable and not electrically conductive. Slide it on and then wipe it off again. So I've exposed the conductor in each wire, so what you have to do now is bend this back round and then crimp this on like that, so that this touches the metal of this using the crimping tool. Okay, this is super fiddly. You can see I've crimped this can't get it off. I've crimped this on here like that. So now I need to slide the boot back down, re-grease this because I wiped it off. There it is, crimped on, until this sits about here facing downwards, so you can push it onto the plug like this. Right, so you can see how these are really neat now, and they're really tight to the cylinder head, which gives me space here if I need, to put other systems in that area.